Hey everybody, welcome to a brand new unit. This is a unit H. We're going to be talking about right triangle trigonometry in this particular unit. This is a fun subject. I enjoy trigonometry. As long as you understand what it is, you should be okay with it. So we're going to start off with something as simple as the Pythagorean theorem. So you want to make sure you understand the Pythagorean theorem. A lot of students know it as a squared plus b squared equals c squared. Basically it says if a triangle is a right triangle, because this all has to do with right triangles, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So make sure you understand that in a right triangle, the two sides that make up the angle, the right angle, are the legs, and then the longest side, which is opposite the right angle, is called the hypotenuse. And so the two legs squared, the sum of them is equal to the hypotenuse squared. Hence, a squared plus b squared equals c squared. We have something called Pythagorean triples. A Pythagorean triple would be the three lengths of the sides of a triangle with non-zero whole numbers that satisfy the Pythagorean theorem. For example, 3 squared plus 4 squared is 25, and 5 squared is 25. So 3, 4, 5 triangle is one that would satisfy the Pythagorean theorem. So A could be 3, B could be 4, and C could be 5. 5, 12, 13 is another one where A could be 5, B could be 12, and C could be 13. That's what they call a Pythagorean triple. It's not a big deal. Don't worry too much about it. But if the three sides happen to be whole numbers, then you've got a Pythagorean triple. That's really all it says. We also can say that the converse to the Pythagorean theorem is also true. That means that if a squared plus b squared equals c squared is true, then we can say, oh, we have a right triangle. And we're going to use this concept to determine if we have a right triangle or maybe an obtuse triangle or an acute triangle. So as we continue with our notes, let's take a look at this concept. So can we show that a triangle is obtuse or acute or right? And this is the way we'll do it. We will compare the hypotenuse squared to the sum of the legs squared. And we'll see if it's greater than or less than or equal to. It's actually a pretty easy concept. This makes it seem harder. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. Don't worry about that. And the same thing with less than. Here's what I would prefer you do. I would get these notes for sure, download them so you can see them, but here's what I do. I basically compare c squared to a squared plus b squared. I kind of think of it, I'm going to use toothpicks to help me show this. So it says, if we had a right triangle, we would see that a squared plus b squared would equal c squared. We would have a right triangle. So what I do is I compare c squared. If c squared is larger than a squared plus b squared, if this length is larger than a squared plus b squared, what will happen is it'll push out larger, and it'll create an obtuse triangle. So I can say, oh, well, if c squared is larger than a squared plus b squared, this has to be pushed out to make that angle obtuse. And so that would be an obtuse triangle. However, if c squared is smaller, it's going to pull in. It's going to pull this side in because this would be shorter than a squared plus b squared, and we would create an acute triangle. So that's how I tell. I simply look at c squared and see if we're going to push it out to make an obtuse triangle or pull it in to make an acute triangle. That's what I do, and that pretty much takes care of all of this page of the notes, just knowing that right there. And so the next thing we'll take a look at are some examples. So stay tuned for that.